Hello and welcome to the Virtual Technology Summit session, Oracle and .NET Best Practices for Performance. My name is Christian Shea and with me is Alex Key, and today we'll go through some tips and techniques for getting the best performance for your .NET application. Now, if you have any questions as we move through this session, please ask them using the chat window. There will be people standing by to answer your questions. So today we'll cover a few topics. First, we'll start out by describing the optimization process through which you can get the best performance with your .NET application. And then we will cover some specific .NET tips and tricks for coding best practices with ODP.NET. Next, we'll do a demo of Oracle Performance Analyzer and SQL Tuning Advisor, which are tools in Visual Studio that can help you tune your SQL and the performance of your application. And finally, Alex will talk to you about the various options for caching to improve the performance of your system. So if you'd like to try any of these out at home, we do have some Oracle by example walkthroughs, which are step-by-step illustrated walkthroughs with sample code that can help you do the same things you're going to hear about today in the session. These are available on the OTN.NET Developer Center website, and some shortened links are available on your screen for the three pertinent walkthroughs related to performance. One is optimizing data access performance with ODP.NET. These are coding tips for performance. Tuning .NET applications in Visual Studio with SQL Tuning Advisor and Oracle Performance Analyzer. These will show you how to use the Visual Studio tools. And using continuous query notification with ODP.NET and Oracle Database will show you how to use CQN for building your own cache. Okay, so if you are working on a .NET application and you want the best performance, what are some of the steps that you should go through to achieve that? Well, the first is you should follow the best practices for coding techniques that we are going to provide you today. This helps you avoid common pitfalls that will definitely give you poor performance, and also use some of the features that we have that will allow you to tune your application for the best performance. And then use our Visual Studio tool SQL Tuning Advisor to tune your SQL. And then use Oracle Performance Analyzer to performance tune your application under load in a real-world scenario. And you can do these tests during testing and also in production load to improve the performance of your application. We will give you a demo and discussion of that a little bit later in this session. Okay, so what are some of the specific tips and techniques that we recommend that you do with your .NET coding? Well, the first is to be aware that the garbage collector sometimes doesn't do things quick enough, or is not aware of the implications of how heavyweight an object can really be in terms of resources. So we recommend that you close and dispose all of your ODP.NET objects explicitly. The garbage collector may be too slow under heavy load. It may also not be aware of some of the resource allocations that are being used with some heavyweight objects like connections. This is particularly an issue with the unmanaged driver, which has a large unmanaged layer underneath the managed layer. So you can use the using clause to achieve this, and we do recommend it for all ODP.NET objects. Another very important thing for performance is to pay attention to your use of connections. So obviously establishing a connection is a very expensive proposition, especially in the middle tier web application. You don't want to be creating a connection from scratch if you can help it. So to help you with this, our Oracle connection class is actually a connection pool. by default. You can turn that off, but by default it is a connection pool. And the two main connection pool parameters are min pool size and max pool size. These are the most important, but there's lots of others. So please see the documentation for all the different parameters that are available to you when you're creating the connection. Now, how do you know what values to use for things like the min pool size and the max pool size? Well, the answer is that we have performance counters available to you that you can use with Windows Performance Monitor. And this provides things like the high watermark for the day, things like that, how many connections are actually in use, things like that. In the recent 12C ODP.NET release, we've added some additional functionality here, so you should try to upgrade if you can. We've added some granularity of monitoring so that you can monitor at the app domain, pool, or the database instance level. So for enabling performance counters, they're not enabled by default because of the implications of performance on your system. You need to look at the documentation for details of the configuration settings to enable it. Okay, so now if you are using connection pooling and you have a cluster, data guard, or golden gate, those items, those entities, they emit metadata about their performance. So in the case of clustering, it will tell us how many for each node how it's performing, and some nodes of the cluster may be really overworked, and others might be less, might have a lot less workload on them. So one of the things you can do is take advantage of connection load balancing. So if you set load balancing equals true in the connection pool, we will automatically weight the connection pool allocations so that the cluster nodes with the lighter usage will be more heavily represented in the connection pool, whereas the ones that are being used heavily in the cluster will have a much less representation in the pool. The other thing that's important is fast connection failover. So if you set HA events equals true in the connection string, basically the connection pool can receive fast connection failover notifications if a node goes down. And what that allows us to do is to clean out the connection pool for the bad connections. And therefore, you do not have to wait for a situation where someone tries to use a connection and then has to undergo a TCP/IP timeout of a matter of seconds to find out that the connection is bad. We get a callback from the database and clean out the connection pool ahead of time. Another very important feature to be aware of for actually programming any code against Oracle is the use of bind variables. So bind variables, basically, you have a select statement with a where clause or something, and in the where clause, instead of saying where employee name equals Smith, you say employee name equals :1 or something like that. So what this allows is it allows the Oracle parser to recognize that the statement has already been parsed in the past. Basically, it'll be the same statement because it has a placeholder instead of a different value, a literal value in the where clause. And so this prevents the database from having to do an expensive parse. So you should not be concatenating literal values to SQL statements in your ODP.NET code. You should be using bind variables. Another important feature ODP.NET offers is statement caching. So what statement caching does is it tells the database to remember the parse information that when it went through the trouble of parsing a statement, to remember it because this particular SQL statement is heavily used. Basically, pin it in memory. So what ODP.NET does is it tracks which SQL statements are the most heavily used and makes sure that they don't get removed from from the cache on the database side. And this is on by default, and we tune the cache automatically based on how many SQL statements you're using. So you don't have to really do anything to take advantage of this feature. Okay, so when it comes to data retrieval, we also give you fine-grained control of how much data comes back every time you need to go to the database. Depending on your use of the network, you probably you want some control of this. Most of the time, you don't want too many round trips because they can be expensive. But on the other hand, you may not want to wait on a ton of data to come back. So what we provide dynamically at runtime, we provide a row size property, which tells you how big in bytes a row is, and then you can multiply that by however many rows you want to return, and you can set the data reader fetch size, which will in turn control how much is brought down for every fetch. And with that, let's go over to Visual Studio and show you how that works. Okay, I'm here in Visual Studio now, and I have open a application that uses ODP.NET, Oracle Data Provider for .NET, and we're going to connect to the database using this connect string. And then once we're in there, we will basically try a couple fetch sizes to see how the performance is, and we'll compare the performance between the different fetch sizes. So first thing you see here is we create a new connection object using the connection string, and we open it. And then we create the command object. We provided a select statement, select star from employees. And we disable statement caching just so that it doesn't interfere with the performance measurement, because it adds statement caching adds its own performance enhancements as well. So we want to disable that just for the time being. It is by default, it will be on. And then we'll make a note of what the starting time is, and then in 100 times we will fetch all the data. So we execute the reader, we set the row size. In this case, we're going to set the fetch size to 1 row. So row size times 1. And then once we've set the fetch size, we can start fetching. And that's what this does, reader.read. And that will remain true until there's no more data left, in which case the while loop will terminate. And then we will dispose the reader and do it all over again 100 times. So this will give us timing for one fetch size of 1 row. So then we'll go down here and we'll see what happens when we set fetch size to 100 rows. And then when we are all done, we will basically output the performance metrics between the two. And obviously, fetch size of 100 ought to be a lot better because we aren't doing a lot of round trips that are pretty costly. Whereas in the case of fetch size of 1 row, we're doing a lot of round trips. Okay, so let's go ahead and run this. And you can see the results here. Fetch size with 1 takes 2.4 seconds, and fetch size of 100 is a much more normal 0.17 seconds. And so there is a very big difference when you use fetch size in certain circumstances. Okay, the next feature I'd like to highlight is statement batching. So you can get better performance by grouping statements into 1 round trip to the database. So there's a couple ways you can do that. One, if you're using the Oracle Data Adapter, you can set the update batch size so that when a data set is changed, only batches of changes are sent all at once to the database instead of 1 round trip for every row. And one other important feature that you can take advantage of is called anonymous PL/SQL. That's when you place PL/SQL in between a begin and an end command as a block, and you can put multiple select statements inside that. or multiple SQL statements inside that begin and end, and then send that all as one block up to the database for execution. So that's another way to do statement batching. Lots of people need to send a lot of data up to a stored procedure. So we always recommend that the way to get the best performance to do that is by using what's called PL/SQL associative arrays. These used to be called index by tables. It's a special format it's a special type of PL/SQL table. And it allows you to pass a large amount of data with good performance. Another concept is called parameter array binding. So we already talked about using bind parameters, but suppose you have to do an update statement over and over again to keep updating a new row, update a statement with a new row every time. Rather than calling multiple update statements and multiple round trips, you can use a array bind variable. Where you put multiple values in the array bind variable, and then only one round trip is used to result in the equivalent of multiple update statements. And promotable transactions is a concept which means that you may have a statement that might need to become a distributed transaction, but you won't really know that until the runtime data is known. So instead of declaring the transaction to be distributed off the bat, you can call it a promotable transaction, and it will start out as a local transaction, and if it turns out that it needs to participate in a distributed transaction, it will do so. So by default, we turn this on. It does require that you need Oracle Database 11.107 or later and ODAC or ODP.NET 11.107.20 or later, because that's where we enabled this. And ref cursors, these are a database feature that represent a pointer to a result set. And we expose this through the Oracle ref cursor class. And the nice thing about this feature is it defers result set retrieval until you actually need to do it. Instead of getting a set of rows back, you just get a pointer to the result set on the server. So some ways you can use this as part of a stored procedure or as part of an anonymous PL/SQL block that we mentioned earlier. You can have multiple select statements, each one of which can open a cursor. And then you can get the ref cursor for that cursor, and you don't actually fetch on it until you want the data. You do have to do an explicit fetch on it to get the data out of it. So again, you can anonymous PL/SQL between a begin and end block. You can do select statements. Another way to use it is to put the select statements inside of a stored procedure and have that stored procedure return an output ref cursor, which you can then in turn bring it down to your client and fetch on that ref cursor as you need the data. You also actually have the ability of passing ref cursors in to stored procedures. So if you receive a ref cursor, let's say from one stored procedure, you can pass it back in to another stored procedure. So you can control the data, how it's fetched by using fetch size, as we mentioned earlier, and it gives you the control to fill data sets with just the portion of the ref cursor result that you want. You don't have to fill the entire data set. And another very important area for getting good performance is when you deal with large objects, or LOBs for short. So that's called LOBs. There's blobs for binary LOBs, CLOBs for character LOBs, and B files for file system large objects. And then that's the basic generic name, but then we introduced a new feature in Oracle 11 called secure files, which is actually a more performant version of large objects. So basically we give you a lot of control over how you retrieve large object data. So one of the most important knobs you can twist is called initial lob fetch size, which hangs off the Oracle command class. And what this allows you to do is control how much data actually comes back when you select from a table that has a large object in it. So for example, if you have a table with images in it, you can tell it, I only want to retrieve the first 1,000 bytes of each large object so I can look at the headers, for example. Or you can say, I don't want to retrieve anything until I actually want it. So you could set initial lob fetch size to 0. And then we expose an Oracle club, an Oracle blob, and Oracle bfile class, which allows you to do chunking. You can retrieve the data in chunks for performance reasons using the read method. We also have a really great search method, so you can search through data to find what you need. Now, you don't always have to bring data all the way down to the client side to do things you want to do on the database. So it's very important to understand that the database has a concept of a lob locator. In other words, in tables, we don't actually put the data there. We have a locator that points to where the data is. That means when you do updates between tables, like to move a large object from one table to the other, we're really just copying that pointer, that lob locator, from one location to the other. So if you need to move large object data from one table to another, don't bring all the data down to the client side and push it back up to the database. Consider just doing an update, insert, or delete statement to achieve that, and that will simply move the lob locator from one table to the other. And I mentioned secure files, which is just an advanced form of lobs. We introduced that in 11G and higher, and it uses the same interface as blobs and clobs. It's just a matter of creating the lobs and clobs using the secure file option. Now, we definitely recommend that you do that, or your DBA does that, because you will get much better performance than using the old style blobs and clobs. Now we'll talk about Oracle Performance Analyzer and SQL Tuning Advisor, which are features of the Oracle Developer Tools for Visual Studio and help you tune your application for performance. SQL Tuning Advisor is used when you're designing new SQL statements to be used with your application. So what you do is you open up the query window in Oracle Developer Tools for Visual Studio, and you tune your ad hoc SQL statements there. You can also tune bad SQL statements that are found by the Oracle Performance Analyzer, which we'll talk about in a minute. So the SQL Tuning Advisor has a few requirements. First of all, you do need to have the advisor privilege. You also need to have the Oracle database license for the Oracle Diagnostic Pack and the Oracle Tuning Pack. You run it by going into the query window and pressing the Tune SQL button. Or if you're using Oracle Performance Monitor, you press the Tune SQL button there. So let's switch over to Visual Studio and do a demo of SQL Tuning Advisor. Okay, I'm in Visual Studio and I have an Oracle Data Provider for .NET application. Now, unfortunately, the application's not performing well because a particular SQL statement that I have right here is not performing well. So what I want to do is run SQL Tuning Advisor on this SQL statement. So I connect in Server Explorer. I've installed Oracle Developer Tools for Visual Studio, and you can see that the data source has odp.net in it. This is very important. You won't be able to see these features if you don't see that. So I'll connect as HR to my PDB RCL database. And once I'm in here, I will go ahead and cut and paste the select statement and then open up the query window. Now I'll paste the select statement into the query window, and I could execute it here, of course, but what I really want to do is I want to press the blue wrench so that I can tune the SQL. So I'll press the blue wrench, and it reminds me I need the tuning pack and diagnostic pack licenses. Okay, once it's done tuning, I have a couple different ways I can view the results. I can view it in this window here, or I can press the View Report button. Now, the report is a very nice formatted document you can give to other members of your team. And it includes, in this case, some findings about needing to create indexes on my tables. It also found that I had an expensive union operation in my select statement, and it suggested potentially using union all. Now, since you can give this document to team members like your DBAs, we've also included helpful information like the explain plan. Now, another feature of the Oracle Developer Tools for Visual Studio is the Oracle Performance Analyzer. So this is a tool in Visual Studio that lets you detect performance issues in your application's use of the database while it's under load. So you will need to have sysdba privileges to do this, and you'll also need to have the Oracle Database license for the Oracle Diagnostic Pack. So you can use this when you're testing your application, but you can also use it to find performance problems with a production instance. Now, the Oracle Performance Analyzer is easy to use. You simply connect to your database in Server Explorer as sysdba. If you're using Oracle Multi-Tenant, you connect to the container. You run your application, you start Oracle Performance Analyzer, and you enter the amount of time to analyze. You need sufficient database time to get results, and that usually amounts to something like 30 minutes to 2 hours worth of runtime. You press start to start the timer, and when it's done, you view your findings and recommended actions. Then you can implement those changes and run it again for additional recommendations. So let's go back to Visual Studio and see a demo of the Oracle Performance Analyzer in action. Okay, we're back in Visual Studio again, and this is the same application we were working on before. Now, we've tuned the SQL, but the application itself is still performing poorly when under load. So to use SQL Performance Analyzer, we will first run the application in a tight loop. Next, I want to run Oracle Performance Analyzer. Now, to do this, I need to be connected as a user with sysdba privileges, and I need to use odp.net as the data source. So I'll connect to sys, and I'll choose the sysdba role. Now, since my database, PDB-ORCL, is part of an Oracle 12c multi-tenant container database, I will connect to that container. But if you're using Oracle 10G or Oracle 11, you would just connect directly to the database. And now that we've connected, we can run Oracle Performance Analyzer. It's in a menu item hanging off of the connection node in Server Explorer. And it reminds us we need the Oracle Diagnostic Pack. Next, it brings up the Oracle Performance Analyzer main window. We need to tell it how long to run the analysis for. Depending on how extensively your application is using the database, you may need to run for 20 minutes up to several hours to get good results. Finally, I press the Start button and the countdown timer begins. And after the timer has elapsed, the results window is shown. So you can see I have several findings here. The two most interesting ones are hard parse due to literal usage and session connect and disconnect. The other two are probably side effects of those. So let's start with session connect and disconnect and take a look at the recommendation. It says I should investigate application logic for reduction of connect and disconnect calls. For example, you should use a connection pool in the middle tier. Okay, well, that's confusing because I thought I was using a connection pool. Let's take a look at the code. In my connection string, you can see I have connection lifetime equals 1 set. This effectively disables my connection pool, and that's my mistake. Now let's take a look at the other interesting finding. Hard parse due to literal usage. And let's take a look at the recommendation for that. It says I should investigate application logic for possible use of bind variables instead of literals. So let's go take a look at the code and see if we can figure out what went wrong. Well, it turns out I am appending a literal value to the end of my where clause in the SQL statement instead of using bind variables like you see in the commented out code there. That's a big no-no when it comes to performance. So thanks to Oracle Performance Analyzer, I can correct these mistakes, rebuild and rerun my application, and then run Performance Analyzer another time to make sure there's no other problems. And that concludes this demo. Now I'll turn it over to Alex Key to talk about caching.
Thanks, Christian. Hi, this is Alex Key. I'm the product manager for ODP.net. And before we talk about caching and the best practices around that, just wanted to remind you that you can use the chat window if you have any questions as we go along. The downside with using just a plain old cache, a dumb cache, is that it'll cache your data, but what happens when results on the server side change? Well, if there's no intelligence between the database and the client, where the client knows that knows what server data is being cached, then whenever you get a server change, people who are using the cache will end up using invalid data, out of date data. What Oracle provides in these caching solutions I'm going to talk about for the next few minutes is the ability to use a cache that has intelligence built into it with the database. Meaning, if the data in the database changes, each of these caches will get updated automatically, or at least provide application logic for you to do updates. And there's several of these. There's the client result cache, there's the continuous query notification cache, and then there's the times 10 in-memory database cache. All of these are available for .NET developers, and all of these are you can use from ODP.net. Now, there are certainly other caches available, such as coherence, but the caches I'm going to talk about are specific to database applications. Coherence itself is a mid-tier cache that works from mid-tier to mid-tier, that caches between different mid-tiers. You can use that with ODP.net, of course, but this is not a discussion of kind of these mid-tier caching solutions, but more of a database caching solutions. Also, I want to emphasize we're not talking about any server-side caches either. These are all caches that are contained on the client side that you can use from the client side to keep the data on the client side so that you don't have to make the round trip to the data to read the cache. Now, each of these caches serve a different purpose, which is why I'm going to talk about all three of them. So let's talk about the Oracle Client Result Cache first. This is a cache will automatically update your query result set. So if you have a query and you're making that same query over and over and over again, you want to be able to store that data on the client side, of course. And then if the server ends up changing the data so that your client result set would be different, you want the server to tell the client result cache that, hey, something's changed. You should update the cache so that users who are reading this client result will get the most up-to-date data. And that's what the Oracle Client Result Cache does. And it does that automatically for you. And it's easy to use because you don't have to have any specific code changes. You do have to make some setup changes by the DBA. The DBA has to set aside an amount of client-side memory to use, how long the cache lag should be, and then when those settings are changed, bounce the database to have them be set in the database server. And then once that happens, then the DBA has to decide what can be cached. So that means you can choose to have certain query statements be cached. You can do that by setting a SQL hint. And I'll show you how to do that in my demonstration. That would be the only code change, quote unquote code change, that would be needed. But you don't have to do that. You can also do it by specific tables that you want cached, or specific users and their sessions that you want to be able to use the client result cache. That's generally the more common ways you can set it, and that is without code changes. Now, this client result cache is not perfectly in sync with the database. It's going to be snapshot consistent. We maintain the snapshot consistency as a performance consideration, and I'll explain that how that happens and why that happens in the next slide. And the nice thing about this is that the cache will refresh itself without any user intervention. It will keep track of the changes on the server side and then be able to inform the client side that the changes occurred so that the client has to be able to refresh its cache. Because we've done this architecture, which I'll explain in a minute, we found it to be very scalable, very high performing. So you can implement this cache without an excessive amount of round trips. We only will do a round trip when absolutely necessary. So when you have a data change on the server side, the client will receive a change notification on a subsequent round trip. What does that mean? That means in a normal database activity between the client and server, there's going to be round trips occurring. When a data change happens on the server side that would affect the cache, the server does not immediately send a notification to the client side. What it does, it waits for the next round trip that occurs and piggybacks off that round trip to the client side. And then the client side then thusly becomes informed of the change and then can make sure to invalidate its cache. What this does is that it makes sure that no additional round trips occur. We piggyback on existing round trips. That way we don't induce any additional network traffic, which is unnecessary. Of course, that means you only have snapshot consistency, but we think this is a valid trade-off to prevent unnecessary database activity. Now, there are sometimes cases in which the amount of time between round trips can be very long if there's not much activity happening between the client and server. So there's this max lag attribute that we have that you can set that says if there are no round trips in the max lag amount of time, so you can set that to 1 second to 2 seconds, for example, then we will force a round trip from the server to client to ensure that the client cache does not stay out of sync long. And certainly you can dial this amount down. You can have much closer consistency between the client and server. Now, when I said the change notification gets set, it's just the change notification. You're actually not getting any new results whenever the server updates the client. All the server is telling the client is that, hey, your results are invalid. So when do the results in the cache get updated so that they're now valid with the latest results? They get updated only when someone initiates a read of that data. The reason why we do that, why we defer actually updating the data in the cache, is that the results possibly could change many times before someone tries to read the cache. If that's the case, you don't want to have constantly updating client results. You want to be able to defer that until actually someone needs to read the results. So that's another way we reduce unnecessary database traffic. And how we decide what gets to be cached is least recently used algorithm. So if you set your cache size to 50 megs or 100 megs, what we do is we store all the most recently selected data into the cache. And then when the cache gets full, the last one that was selected gets aged out. So that's how we keep the cache updated and new. So let's take a look at the client result cache in action. So what we have here is an ODP.NET application, and we're going to show you the client result cache. We're going to time it between using the cache and not using the cache. So let me extend this to full screen so you can see everything. What we're going to do is we're going to first select some columns from the employees table in the HR schema, and we're going to time it. We're going to execute it 20,000 times, the same query, and we're going to read the results all the way through. So it's starting time and then ending time, and we're going to see how long that takes. That will be without the client result cache. So this is the base measurement, and then we're going to measure it with the client result cache. This time you'll see the same queries being executed, but with a difference. We've added the result cache hint. The SQL hint is here, and that's one way you can enable the client result cache for specific statements. As I said before, you can use it with specific users, or you can enable it for specific tables. It's up to you how you want to set it. But for this demonstration purposes, I'm going to do it for this specific query so that we can see it in action and compare it with the non-result cache. So we'll execute the same 20,000 times and see how long it takes. So let's execute this. And if I zoom in here, okay, there we go. As you can see, there's a 8.5 second time it took to do the results, the reading of the results when the cache was disabled, and then when the cache was enabled, 2.5 seconds for about a 240% difference. So a very significant difference between the caching disabled and the caching enabled. But of course, this did not demonstrate how to use the updatability of the cache, right? The whole purpose of this cache is that, hey, the server can update the data and the client side can get the results back. So let's take a look at the second part of this application. And what we're going to do is we're going to just do the same query, execute it. See the execution here. And we're just going to read one of the results and output it to the screen over and over again. And when I do that, I'm going to then go to the tools side and make a change to this data on the server side. And when the change happens on the server side, you'll see about a second delay, because that's how long I've had the max cache lag to, and then the update will occur. So you'll see about a second delay when that happens. And the reason why you see that second delay is that I'm just reading the results. I'm actually not doing any round trips. And since I'm reading results from the cache, there's no round trip activity occurring. So you'll get the maximum cache lag hit. And you'll see the cache lag come into action, and you'll see that the results get automatically updated. So let's run this. And let me set up the system here so that you'll be able to see things a little clearly. So we'll set this to the left. And I'm going to open up the tools window here. And here I've done a query of the employees table. And you see that the salary for the first employee is 7,000. And we will see that 7,000 is being output to the screen right here. And what I'm going to do is I'm going to modify the salary to 8,000. And as soon as I toggle off, which I'm going to do in a second, as soon as I toggle off, you'll see the change happen after 1 second delay. So let's do the change in 1, 2, 3. And you saw the change happen after a 1 second delay. If I do it again, if I change it back to 7,000 from 8,000, and I do the change 1, 2, 3, you'll see that there was a second delay there too. What we see is that the change gets propagated from the server to the client at the maximum amount of time because there's been no round trip activity. But certainly in a normal running application, you're going to have this regular activity. So you probably won't ever hit the maximum cache lag. But if you are concerned about that, you can always set that lower if you want. That is a customizable setting. So that was the client result cache. Let's talk about the Oracle Continuous Query Notification. The Continuous Query Notification, or CQN, is different from the client result cache in that it's much more programmatic. You have a lot more control over how the cache works, what it does, and what you can do with it, what happens upon a change, things like that. Of course, that's the downside. You have much more control, means that you have to do much more to control it. You have to add more application logic. So the benefit is that it's more programmatic. The downside is that it's more programmatic. This feature was also known as database change notification at one time. So if I talk about database change notification or CQN, I'm just talking about the same things. I've outlined at a high level what are the benefits over the client result cache, but more specifically, what does that mean? For example, in the client result cache, when it stores the cache for one user and that user does a query like select star from employees, it'll store that. If another user with another user ID does select star for employees, well, it'll store that result as well, but not share the results between the two. That's not great. You basically are storing the same results in the cache. So CQN can do that for you, where you can have all different users access the same cache. That's great. That's what CQN is made for. So different usernames can all access the same cache. What if you only want to store a subset of that data, only the last 100 rows? Client result cache stores everything that you queried. CQN, you can define what set of rows you want to be able to up to date with the cache. You can also decide how long the query is to be cached. You can decide if you want it to be a long time, a short time. Do you want additional logic to be executed when the cache is refreshed? You can do that. You can add additional logic, and I'm going to show you a demonstration of kind of how you do that. So again, the downside of that is that you have to program all this in. You have to make the settings so that you can have the cache operate in the method you want it to operate in. Because of that, we introduce many new sets of objects and APIs. And let me talk through those in this visual demonstration, and then I'll show you the code demonstration. So on the left side, you have your application. On the right side, you have your database. What we create is an Oracle dependency to get CQN started. And this Oracle dependency is added to an Oracle command, so that when a command is executed, you'll get a notification request, and that'll be added to the data dictionary. So upon the execution, the data dictionary is made aware that these results need to be kept track of. So what then gets created on the client side is a listener. Now, why is a listener created? Well, that's actually one of the advantages of having CQN. You no longer need a connection to exist in order to update the cache. All the connections could be severed, but as long as you have the network available, the cache will get updated, or I should say the on-change event handler will be launched. That's the more technically accurate way of saying it, but most everyone's going to put some update logic inside the event handler. So I'll just say the cache will get updated. So let's say a data change occurs. The table changes, and the data dictionary is aware that whenever there's a change to it, a notification needs to be sent. It gets sent off on a notification queue, and a validation message gets sent from the server to client out of band to the listener. And the listener then launches the on-change event handler. In the on-change event handler, the developer will then add whatever application logic that he or she wants to do when a change occurs. And generally that means updating the client-side results, but it could include other activities. So let's take a look at what you might be able to do with this. We have another C# application using odp.net, and we're going to do a select star from employees. And what we're going to do is then we're going to add the row ID because we're going to do some application logic with it. So we'll add the row ID to the query, to the command object, and then we'll create our dependency object, which I mentioned. We can then bind it to an Oracle command, as you can see it right here. And what this does is an Oracle notification request is created and is set in this Oracle commands notification property. We'll also make a setting change. We'll set the is notified once property to false. And what this does is that every time you get a server change, you'll get another unique event handler get launched. So that basically means anytime these results change, the listener will get alerted, and then the event handler will launch. That way, if there's 3 changes happen one at a time, you'll get 3 notifications. By default, what we have is that upon the first change, the notification registration in the database goes away. But if you set it to false, the notification registration will persist. So that's what we're doing here. And what we need then is an event handler. So we add the on-change event handler called onMyNotification. And then we just execute the query and let it sit. We don't need a connection anymore because the listener will be up. And let's see what happens on the onMyNotification event handler. So we get returned this Oracle notification event args, which we can use to get some metadata about what changed. And the first thing I do is I show a message box just to demonstrate to you that, hey, the event handler got launched. We'll launch the message box first. And then normally what you want to do when event comes along that says the results are out of date is to update the results. So what we're going to do is pull from that Oracle notification event args the first row of data, and get the row ID from there. And that row ID will allow us to populate from that original query, select star from employees, where row ID equals that row ID, and then add additional row IDs for every row that's changed. So it could be a multiple row change. That's okay. And in this case, I'm only going to retrieve the results that changed rather than the entire query again. The easiest thing to do is retrieve the entire query again, but I would just want to show a situation where in the application logic you can be more customizable why you would use it. Certainly if you're retrieving millions of rows, you probably don't want to retrieve millions of rows over and over and over again if only 1 or 2 rows are changing. If that's the case, you just want to retrieve the rows that changed. And then we just refresh the data by requerying for those changed rows. And that's it. So let's take a look at this. We'll run. And we see the table here. And let me minimize this a little bit. And we see that the first row has a salary of 7,000. I can zoom in here. The first one is 7,000 for employee 100. And what we can do is start changing the values. So if I change that to 8, we see we got the notification alert. Result set has changed. If I change it again, we get the, once I go off the cell, we get the notification. Once I hit OK, we can see that the result changed to 9,000. I do it again. I'll change it back to 8,000. Say OK. It's 8,000. So you can see that every time the data changes here in the Oracle Developer Tools, I'm making a change to the results on the server side. The salary on the employee table gets changed, which is cached. So it automatically gets the alert and then does a requery of those specific rows that changed. Now I showed you that you can change multiple rows and only those rows will be changed. Well, let's initiate a query where we update multiple rows. Here we're going to add $10 to the salary where the employee ID is 100 and 101, which means the first two rows should increase the salary by 10. So if I run this, we get the result set has changed, and we can see here, if I zoom in, that both of them have been increased by 10. If we run it again, we get result set has changed, and it's increased by 10 again to 20. So here, very simply, you can see how CQN is very customizable. It allows you to do a lot of different things, certainly a lot more application logic than what you had to do with client result cache, but the benefit is that you can do anything you want. The last cache I wanted to talk about is the times 10 in-memory cache, and this is definitely the most powerful cache in terms of fastest updatability. The response time you get in the updates of the cache are in microseconds. It's very, very small, very, very quick. And that's because the cache is in process with ODP.NET, with your .NET application itself. Because of that, it's very fast. Any server updates get reflected very, very quickly on the client side. Now, the times 10 in-memory cache is a full-featured relational database. It's fully compatible with Oracle SQL and PL SQL. It's persistent and durable. It can do transactions and have ACID properties. And it's very, very fast performing, high throughput. It's really meant for the most high demanding performance applications that need to have very fast updates. Now the downside is that it is a full-featured relational database that you're hosting. There's configuration needed for ODP.NET. You need to use the ODP.NET times 10 provider. It's the same ODP.NET APIs, but you're using the times 10 provider. So you have that sets of demands that I don't want to call overhead, because that implies that it's slower. It's actually faster, but it's an overhead from a setup operational standpoint, but not overhead from a performance throughput standpoint. It's more work to configure, but it's very fast for those who need that. So that's kind of the advantages, disadvantages of times 10 versus the other caches. So I want to thank you all for listening today. Those were all kind of Oracle's tips and tricks for how to optimize using the Oracle database with .NET, with Visual Studio. I hope you learned something, and feel free to ask any questions you want in the chat window. And happy coding. Thank you.